Hey students, in this video we're going to go through 8.6, which is about polygons in the coordinate plane. Our learning target is I can draw polygons in the coordinate plane and find distances between points in the coordinate plane. So up here it tells us you can use ordered pairs to represent vertices of polygons. Remember, vertices are where some lines are going to intersect, like the corner of a square. To draw a polygon in a coordinate plane, plot and connect the vertices. So just plot the points and then connect them. It's like a dot to dot. So in example 1, we're going to do just that. The vertices of a quadrilateral of a four-sided figure are vertex A, negative 1, 1, vertex B, 0, 6, vertex C, 4, 5, and vertex D, 5, negative 2. Draw the quadrilateral in the coordinate plane. So first, we're going to plot all 4 of these points. So point A is at negative 1, 1. So remember, start at the origin. We're going to walk left 1 for negative 1. We're going to take an elevator up 1 for positive 1. That's point A. And we label it with whatever label they've given. Next, point B, start at the origin. We are not going to walk left or right since x is 0, but we are going to take an elevator up 6. Now it only goes to 5, so 6 is going to be just above that. There's point B. Point C, we're going to start at the origin. We are going to walk 4 to the right because x is positive 4, and we're going to take an elevator up 5 because y is positive 5. That's point C. And finally, point D, we're going to start at the origin. We're going to walk 5 to the right because x is positive 5, and we're going to take an elevator down 2 because y is negative 2. So those are my 4 vertices of the quadrilateral. Now to actually draw it, I'm just going to connect it. I really should take a ruler to make the lines more straight, but I'm going to just do my best to connect them. There, there, and there. And there we go. We now have a quadrilateral in the coordinate plane. And that is all this is asking us to do, is to simply draw that quadrilateral. Plot the vertices, connect the vertices. Next, we're going to talk about how to find the distances between points in a coordinate plane. Of course, you can graph them and count the distance that way, but what if you don't have a graph in front of you? You can find distances between points in a coordinate plane with the same x coordinates or the same y coordinates. So this only works if your points have at least one of the values in common, if their x's are the same or their y's are the same. You can do this using the absolute values of the coordinates that are different. So if the x's are the same, we're going to use the absolute values of the y's. If the y's are the same, we'll use the absolute values of the x's. So we have some examples. So if we have points that are in the same quadrant, these fall in the same quadrant. They both have negative x's and positive y's. That's how we know they'll be in the same quadrant. So we are going to take the absolute values of the coordinate that is different. So we can see y is the same, x is different. So I'm going to take the absolute values of the ones that are different. So the absolute value of negative 6 and the absolute value of 3. And I am going to subtract these because they are in the same quadrant. So if my points are in the same quadrant, I take the absolute value of the points that are different, their x's are different. So absolute value of 6, absolute value of 3, and I'm going to subtract them. The absolute value of negative 6 is 6. The absolute value of negative 3 is 3. 6 minus 3 equals 3. Therefore, the distance between these points is 3. 1, 2, 3. We can count that for sure. Let's also just make sure we note that these had the same y value of 2. That is why we used the x values. That's why we subtracted the absolute value of the x values. Now, what if you have points in a different quadrant? These ones are in different quadrants. We have quadrant 1 and quadrant 4. We can see they're in different quadrants because even though they have positive x's, this y is positive and this y is negative, so they're in different quadrants. In this case, we are going to add the absolute values of the coordinate that is different. So we can see here we have the same x value of 2. So I'm going to take the absolute values of the y value. So absolute value of 1 and absolute value of 4. And I'm going to add them because they're in different quadrants. So absolute value of 1 is 1. Absolute value of negative 4 is 4. 1 plus 4, we get a distance of 5. And we can count that on our coordinate plane. 1, 2, 3, 4, 5. I know that's kind of funky, but it's just a set of rules that we want to just follow. So we have to decide, do they have the same x or same y? Okay, so we should take the absolute value of whatever is different, and then depending on if they're in the same quadrant or different quadrants, we'll either subtract or add. Again, I know it's kind of weird, but let's just do some examples. So it says find the distance between -3, 5 and 2, -5. So I'm actually going to show you on the graph and using the method we learned above. So let's graph both of these. So the first one, we'll start at the origin. We're going to walk 3 left because x is -3, and we're going to take an elevator down 5 because y is -5. So here is point -3, comma, -5. I'm labeling it just so I know where it is. It's easy to tell. And then I'm going to graph to -5. So again, start at the origin, walk 2 to the right because x is +2, take an elevator down 5 because y is -5. So this is the point 2, comma, -5. So remember, we can only find the distance if they have one value that is the same, the x's or the y's. We can see here it's the y value that's the same. They both have a y of -5. So they have the same y of -5. That means I'm going to need to take the absolute value of their x values, the absolute value of -3 and the absolute value of 2. The question is, do I add or subtract them? Well, remember, that depends on if they're in the same quadrant or different quadrants. These are in different quadrants. Therefore, I am going to add them because in different quadrants it says to add. So I'm going to add the absolute value of their x values. So the absolute value of -3 is 3. Absolute value of 2 is 2. 3 plus 2, we get 5. The distance between these points is 5. And we can count that here. 1, 2, 3, 4, 5. Okay, our next one, find the distance between 3, comma, -2.5 and 3, comma, -5. Again, we're going to graph them, but also show the math. So first, start at the origin. We're going to walk 3 right because x is +3. And we're going to walk 2.5 down. 1, 2.5 because x is -2.5. So here's my first point, 3, comma, -2.5. And my next one, start at the origin, walk 3 to the right because x is +3, take an elevator down 5 because y is -5. 3, comma, -5. So remember, we can only find the distance between points that have at least one value in common. These have an x value in common. They have the same x value of 3. That means I need to take the absolute value of the y values because that's what's different. So I'm going to take the absolute value of -5, sorry, and the absolute value of -2.5. Now the question is, do I add or subtract these? Well, these points are in the same quadrant. Same quadrant means we need to subtract them. So I'm going to subtract these. The absolute value of -5 is 5. The absolute value of -2.5 is 2.5. 5 minus 2.5, I get 2.5. The distance between these points is 2.5 units. Again, I can count that on here. 1, 2.5, 2.5. So ultimately, I would really encourage you to graph these points in order to find their distances, but just know we still can do it without a picture. They just have to have one value in common, either x or y, and then you take the value they do not have in common, find their absolute values, and either add or subtract, depending on if they are in the same quadrant or in different quadrants. But again, I would really encourage you just to be using a graph, plot both points, and count the distance that way.